Alright, I am Ismail from UC Kuala Lumpur, British Malaysia Institute. Today I will talk about the timer, right? Timer, the fundamental principle of timer, and the operating modes. The programming I will support with another video later on. So today we talk just the theory of the timer, and we right. So first of all, let me know what is timer used for. What's the timer are used for? Timer is used to count files, right? It's like that for time measurements, signal generations, that it's produce some sort of like pulse width generation, and event tracking. Maybe it can be used for counting, for example, counting number of events. It can be used also to count the time elapsed between the time taken or elapsed between the events. And so in general, we have about 4 different modes of timer, which are time-based, pulse width modulations, counter, and input capture. Right? So basically, there are a lot in programming. Yeah? There are a lot in programming, such for frequency measurement, for example, or for example, for the distance measurements, when you use LiDAR, whatever, microwave, ultrasonics, and so on. All right. First of all, let's look at the block diagram of the. Actually, that is the counter, right? Binary counter. So, how the binary counter works? It will count up, right? Counts up. We talk about the counts up counter, right? We not talk about down counter. Basically, in general, our timer, right? The timer that's supported by STM32 processor can work up and down, can count up and down. We can do it, right? We can do it. But for the understanding of the timer, let's talk about a simple binary counter, which count up to the maximum. For example, say we have 4-bit counter, so we count from 0, 0, 0, 0, for example. Let's say start at 0, 0, 0, 0, 4 times 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, up to say 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, then 1, 1, 1, 1, 15. And 15 to power 4 minus 1, that is maximum, is count up. Then it will roll off to 0. From 1, 1, 1, 1, then we roll off to 0, 0, 0, 0. So we take advantage when it is roll off, right? When it is roll off, right? When it is overflow, in other words, right? When it's overflow or roll off. So it will generate the interrupt. So we take that, right? So that's the idea, the idea of it. So here we can see that the total time interval that taken for the counter to count up. Say we have from, say it is we have 16-bit counter, so it can count up from 0, 0, 0, 0, 0, or 0 up to 65535, and 2 power 16 minus 1, right? Then we roll off. Say we start at 50,000, right? When we start at 50,000, then it will count up until 65535 and then roll off to 0. So how to calculate it? The time taken, so it's simple. What is the maximum count? 65535. Then we minus with the CRST, right? This account, right? This account. So this count is 50,000. So 65535 minus 50,000. So we got what? 15535 plus with 15536. Then multiply with the T clock. What is the clock? The fixed clock interval. Say we have 1 microsecond. So it takes about 15,536 microsecond for that operation, for that complete count, right? That is the ways. Okay, right. So we go to the first time-based mode, which is the time-based mode operations. So in this, we have the clock input, internal clock. Normally, we use internal clock. Why? Because we need the fixed interval time, right? We use the external or events, so that's not what fixed interval. We feed it to the prescaler. Why prescaler? Because we want to divide it, right? We want to divide it. Maybe the frequency is very high, right? Then we need to reduce it so we can work at a lower frequency. And then it feed the counter. So the counter, simple counter, just a counter. So the counter will count up, right? And then in that block, also we have the auto reload register, ARR register, right? Normally we call it ARR register. So at each of the time, the comparator will compare the value inside auto reload register and counter. Whenever the value inside the counter and auto reload register are equal, then it will reset the counter. It will reset the counter to 0 again. So we can see here, the counter count, say from 0 up to the end. What is n? N is value inside the auto reload register. So whenever it is equal, right? When it is equal, then it will reset to 0. It will reset to 0 and then start again the count, right? Then reset again to 0. Whenever auto reload register and counter are equal, value inside it are equal. Then whenever it is equal, right? They are equal. Then the timer EGR UG will be generated, or the flag will be generated. So here we can say that when CNT or count equal to ARR or auto reload register, a flag is triggered, a flag is triggered and signaling a complete period, right? So we can have a period that based on the that triggered by that flag, timer EGR UG, and the counter reset to 0. So the idea is very simple, right? The idea is very simple. Later we will use it in, normally we use it for time base. We use for time delay, for time delay. Okay, the second mode that we have is counter mode. In counter mode, we use the external trigger, of course, because we're going to count the external events, right? The external events, whatever is it. So we feed it to the prescaler through each detector and polarity selector. So we can select the polarity either positive or negative, each detector positive trailing or negative trailing. We can select that. I feed to the counter. Same, they are the same. Similar to the previous mode, whenever auto reload register are equal to the counter, then the comparator will produce the result, the equal, we generate the equal flag to reset the counter, and at the same time also we enable and we'll generate the flag, UG flag, so that will will trigger the processor, saying that okay, the counter already completed, count completed. Right, so that is the counter mode operations. I can say that I use these modes, I think 0.1% of my project. I never, it's really rare I use this. But you can use it maybe for, maybe some of you like the parking, smart parking system, maybe. You can use it to count the number of cars enter the parking lot, right? And leave the parking lot. Or you can use it for counting the, the number of attendants that attends any events. For example, enter the library, right? Or leaving there, entering and leaving the library, for example. Another one that we have, right? The pulse width modulation modes, right? Pulse width modulation modes. Okay, if you see here, we use auto reload register and counter, right? Auto reload register and counter for both two previous modes, time-based and counter mode. But in the pulse width modulation mode, we added another comparator. So we have two comparators that compare, counter, and also capture, compare register, CCP. And sometimes we call it CCR register. In PIC, sorry, call it as CCP. Capture, compare, and PWM register. Alright. So how it works? Again, we need the fixed interval. So of course, it must be the internal clock. Into the clock, right? And then fit to the prescaler to divide. Of course, we can have, it means that we can have the different period of PWM frequency, right? PWM frequency. All right, auto reload register handle the what we call the period, right? The period of the PWM handled by the auto reload register, while the duty cycle is determined by the value inside the capture compare register. That's the first idea. You should know. All right. So how it works? When the counter comes up, then the value inside counter, right, will be compared with the auto reload register and also the capture compare register. If the value inside the capture compare register greater than the counter, right, greater than the counter, the output become 1. If the input inside the capture compare register equal to the counter or less, the timer CX or the output share, the pulse share, will be 0. Okay, got the idea? So if I set CCR to 0, so this one becomes 0. If I set CCR to 100, while counter less than 100, this one become 1. So whenever this the counter reach 100 and equal to the capture compare register, which is 100 too, then this becomes 0. Say our auto reload register is 1000. That means that from 100 to 1000, this one becomes 0. Right? So 100 times become 1, and 900 times, we can say time, or period, not period, time, become, or clock, become 0. So we can have that, you can see that the duty cycle is 10%, sorry. The duty cycle is 10%, 100 over 1000. So again, auto reload register holds the period, and then the CCR hold the duty cycle. So whenever the count equal to auto register as previous, counter will be reset to 0, and then all over about process restarted. All right, next, the final one, we have the input capture, right? Input capture mode. In input capture mode, we have, of course, we use the external trigger because we the applications of the input capture mode is to capture, right, the time events, the elapse, right, the time elapse of the external events. So after the ETR, right, external trigger, ETR is actually is the pin that we can select as the input for the external trigger. It depends on the timer that we use. So it fit to the each trigger, each detector and polarity selector. So we can select falling rate, falling, or rising, or falling and rising, or rising up to us, and fit to the prescaler, fit to the prescaler. And then inside we have the inputs that fit through the prescaler to energize or counts up the counter. So the counter will count up, counts and count and count and count, right? Whenever it is equal to the value inside a 2 register, then it will reset and carry on that way, right? So whenever it is roll off, okay, then we can increase the external counts, right? For example, let's say we have the the clock that count from 0, that clock count from 0 up to 100, let's say. So each time we reach 100, then we roll off to 0. 100, then roll off to 0, 0, 0, and 0, and 0, in the way, right? That way. So we need to know how many elapsed, right? How many cycle it's already counts up, already counts. Then we take the external variables that way, right? Whenever timer EGR UG interrupted. From that we know the overall, the loops, number of loops. Over there I show you, I take a red color here, to showing that it is overlooked. The count is over, right? Then whenever there is external trigger from external, right? There is external trigger from external. Then the value, the present value inside counter will be captured by the CCR register. So we can take it and put it into our process of programming, right? For example, here, whenever it's happened, then we read the value inside that green color one. And here, the green color one, we have the value. So from that, then we can use to calculate the time taken for that for that events. And I see you. I think maybe we can see it later, right? Yeah, I see you. Okay, the time-based programming, we can have of course processor. We can have polling mode and interrupt mode, right? So time-based polling mode, right? We use for the time delay, right? For time delay, I use it for the ST11. I use it for the ST11. This is the here I show you the the functions that based on the timer, right? The timer in polling mode. And next we use the time-based interrupt mode, and interrupt mode in the what to generate the fixed time delay. So we use the callback here, right? Period time elapsed callback here, and also counter. We used to we use count, but yeah, please watch next video for that. Then PWM, right? PWM, okay. And the last one that we have the sure what I'm saying, the input capture mode, right? In the input capture mode, so we can have first rising or falling, right? Then here you see here when start, right? We have start, we have a loop, right? We call it as loop, right? Then we have end, right? End here. So CT equal to L plus multiply with O plus E minus S. L is the number of counters overflow, right? O is the number of count per overflow. S is start count here. E is the end count. So we can calculate that the number of the counts from here to here, right? We need to include two loops here, right? 1 and 2. 1 and 2 here. So say this is 100, between this is 100 and 100. So we have 100, so we have 200, right? 200 because 2 multiply with 100 minus with right, plus with n says 10 here, right, and minus with 20 because start just 20, so total we have 190, right? 1990 counts and count, and then multiply with the t clock, then you got the time taken. Okay, that's all for the introduction to the timer, operating, basic operating, and also the modes. About the program, please visit my next video. Okay.